Trigonometric identities. I'm Anil Kumar and I'll take you through a few simple steps which will help you solve trigonometric identities. I have two very similar identities here and I'll solve them using very different methods. Now the first one here is sine square x divided by 1 minus cos x equals to 1 plus cos x. The other one here is tan square x divided by 1 plus tan square x equals to sine square x. Let's begin with the very first one. Now here we are given the numerator sine square x, in the denominator 1 minus cos x. What we need is 1 plus cos x. Now 1 minus cos x times 1 plus cos x gives you sine square x. Let us see how. So what we are going to use here is the Pythagorean identity, which is sine square x plus cos square x equals to 1, right? So I can write sine square x as 1 minus cos square x. We'll begin with the left side and write sine square x as 1 minus cos square x divided by 1 minus cos x. Now the numerator can be factored as 1 plus cos x times 1 minus cos x, correct? Difference of squares, and the denominator is 1 minus cos x. Now 1 minus cos x cancels out and you're left with what you need, 1 plus cos x, which is the right side, correct? So that is the strategy which we applied using the Pythagorean identity. Now here we could use Pythagorean identity and solve it straight. Let me show you how. 1 plus tan square x is secant square x, and secant square x is 1 over cos square x. So I could replace that by cos square x and get my result. But I'm not using this, leaving that for you, right? So you should adopt this method and solve this. So you could use Pythagorean identity to solve this. But what we'll use instead is a different strategy. The idea is to teach you different strategies rather than give you a solution. So we'll begin with the left side again. But this time my strategy is to write tan as sine over cos. So I'm writing tan square x as sine square x over cos square x, correct? And in the denominator also I'm writing tan as sine square x over cos square x. Now we'll take cos square x common, right? So we could write this as equals to, in the denominator it is like this, it is sine square x divided by cos square x, correct? That is the numerator, and the denominator, when I take this common, I'm left with, and I'm taking it up. So this is actually sine square x cos square x divided by this, right? Which I could now write as, in fact I could have written it over there. Let me write again. So I could write this as sine square x cos square x divided by 1 minus sine square x cos square x. Do you get the point, right? So that is to say, when you multiply it reverts, right? So you could write this as cos square x over, so this goes here, so it is cos square x plus sine square x. Now cos square x cos squares cancel out and you're left with sine square x. Since cos square x plus sine square x is 1, correct? So this number is 1. So if I do common denominator, I get cos square x plus sine square x, which is 1, divided by cos square x. I'm taking it up, writing it here, they cancel out, you are left with sine square x, which is equals to right side, correct? So that is how I have got my left side equals to right side and proven the identity, right? So these are two different ways we could have done it. You could have written 1 plus tan square as secant square x, then tan could be written as sine over cos, and then when you multiply by cos square x, you are left with sine square x. So that is how you could have done it. So the idea is that these identities can be proven in different ways. Adopt the best and the most efficient method of solving. That should help you. I hope it helps. Thank you and all the best.